Thank you for the kind introduction. It's always a pleasure to be here in this amazing conference. So today I'm going to talk to something completely new. You never told about this in the last 2 years. The topic is generative AI. Wow. So this is the agenda. My goal is to convince you that generative AI is here and you should start using in your daily job. And actually try to use it for developing application on top of this model. Because, you know, the future is here and we need to be prepared for the future. So I will introduce the topics, because a little bit of theory, a little bit, because the theory is huge. I did almost a PhD on that, and literally is huge, and is becoming huge every day. But the goal is to show you that it's possible to do in PHP. You don't have to switch to Python. That is another language that starts with P. So a couple of examples. On the left, you can see a picture that I made using DALL-E 3, that is an OpenAI service, using a prompt. A prompt is a text. I'm just describing what I want to have, and the model itself produces the images. And the prompt was a busy developer working on a laptop during a conference. On the right, we have a...
Good morning, PHP developers. How's it going? Are you enjoying the conference? I'm Onyx, an artificial voice generated using OpenAI and PHP. If you want to know how I've been generated, following the Enrico's presentation. Bye-bye.
So this is another example, 2 lines of code of PHP. I used another services, that is text-to-speech of OpenAI, that produce this kind of, audio quality. You can choose different voices, different personality, you can change the speed, you can do literally what you want. Okay, so what is generative AI? Generative AI is a subset of deep learning. That is topics of artificial intelligence that is used to generate text, images, media, models, whatever. So using this model, basically you generate other output in a creative way. I will try to define what means creative here. So basically this kind of model have to learn from a lot of data, typically billions of data, and they basically try to connect the dots, try to learn the pattern and the structure behind the data. That's what the goal of this model. And the output is something similar to the data that the model digests. So the always sentence garbage in and garbage out is true in this model. So if you put garbage, you will get garbage. So it's very, very important, the quality of the data that you put in the model. In fact, the main research, the real business value of the company behind this model is the training. That's why a lot of companies didn't tell you how they did the training, right? When they say, oh, we released a new open source model, but they give you just the output. Yes, it's open source, I can use it, but it's just a giant matrix of numbers. So I don't know how did you find this solution, right? So this is also important to understand. And it's used everywhere now. So everyone is using this Gen AI. We also recently changed our motto of Elastic as a search AI company. So there is something important going on here. The market is huge. These data are not updated anymore, but just to give you the sentence of, we are talking about billions of dollars, and with an increase of 10% in 10 years. So it's literally crazy. Behind all this model, there is a mathematical object that is called neural network. So what is a neural network? It's kind of mimicking the human brain in the sense that the human works using, cells, using neurons that are connected to each other. So in our brain, there are a lot of neurons, hopefully, connected to each other in a very complex structured way. Mathematically, this is back to 1960, so we are talking more than 16 years old. Some scientists try to reproduce this model with a very basic function in mathematics. So imagine you have some kind of input, a number of arbitrary input, and you want to generate an output. You do the sum of all this input. Input, I mean numbers, because in mathematics, everything is a number, right? So you get the input of this, you do the sum, you do some calculation, and you get the output. Very simple. I will show you in a minute. These nodes typically are collected in layers. So you have to imagine in columns, because you have to build a structure for this neural networks. And if you are more than 3 layers, we call it deep learning network. So when you listen this terminology, deep learning means you have more than 3 layers inside this neural network. So just focus for, I promise, this is the only slide with a couple of mathematics. Sorry for that. But just to give you the sentence, the flavor of what's behind the scene here. So let's focus on a single couple of neurons. So on the left side, we have 2 orange boxes. This is the input layer with some numbers, 0.8 and 1.2. We need to sum together this number with some weight. So this is the connection that has another number. It's the weight of the connection between the neurons. This is the sum. You have a bias that is a constant that you have to add to the model itself. And at the end, you have this activation function. This is very important. So this is a function that says, okay, what number do you give me? Okay, 3. Okay, the output is 0. Minus 1, the output is 1. So it's the one that decided what the next number will be. And you have to concatenate this in this full picture of network. So basically, there are a lot of possible activation functions. One of the simple is the ReLU activation. So basically is GC, where G is this yellow box here. C is the number that you put as input. If the number is greater than 0, the result is C. Otherwise, it's 0. So if you want to plot this in a diagram, this is the function, so very simple. All the negative numbers are 0. The positive is just the number itself, right? Pretty straightforward. So we need to do this calculation. So we are just multiply x1 with w1 plus x2 with w2 plus b. At the end of the game, we have 2.2. So the number here is 2.2. So if I apply the function itself, since 2 plus 2 is greater than 0, the output is 2 plus blue. So this is the logic, the mathematics behind this kind of model. A little bit more sophisticated, but more or less, this is the logic. Right? Okay. Imagine now to put together a lot of these neurons all together. The goal of a deep neural network is to giving input and produce output, right? So at the end of the game, the results is the number that you put on these lines, the weights. So you have to imagine that when you train a neural network, the output is a giant matrix of numbers that are the numbers that you put on each connection in the nodes. When you have this number, it's pretty straightforward. You can run it in a normal CPU if the model is not big, or if you need very, very big models, you can use using GPU. That's why NVIDIA becomes so famous recently, because everyone is using a GPU to do this calculation, even because you can parallelize the tasks, right? So it's very convenient to use the GPU. So thanks to the game industry, now we have a GPU processor that we can use for running this model. Okay, so basically generative AI in this picture is just a little subset of deep learning, machine learning, and artificial intelligence. So there are different algorithms depending on where you're looking for. Okay, so now that I defined what is a neural network, I can define what is a large language model. It's basically a neural network with many parameters. With many, I means a lot, billions of weight, or even more. The bigger is the model, the better is supposed to be the output. That's the trend. That's why company like OpenAI every year announce a new model, and they didn't recently. I don't know if you follow the presentation about GPT-4o, where O means Omnia, kind of the vision of what the power of this model is pretty amazing. So a message, so the large language model works with sentences, right? With text. So how I can use a text, characters, into this neural network? I have to convert the text into numbers, right? And this is called embeddings. When you read, we need to embed the data, that means I have to translate something that can be a text, but can be even an images, a sound file, whatever, an audio file, into an array of numbers. Because the input is the input of a neural network, so you have to provide an array of numbers. And usually, since you can have a very big input, you split this input into tokens. Because the tokens is the unit of, you know, the information behind a large language model. Okay, so the goal of this model, what is try to predict the next word. So you start a sentence that typically is a question. If you try ChatGPT, you know what I'm talking about. You provide a question, but it's actually a sentence. You put as input to the model, and the models try to understand the next word that are more probable, because he knows, the model, it knows, because he has a lot of, you know, document digest. That's why. Since it's really big, this neural network, no one fully understands how it works internally. This is very, very important. That's why I put underline this. Because even the author of the inventor of the transformer architecture, that is the model that drives the majority of the LLM out there, they don't understand how, for instance, ChatGPT is able to do calculation. No one knows. Because if you ask something to ChatGPT to do some calculation, and I just say that the LLM just try to complete the sentence, I can imagine that in some way there are some documents inside the memory of the LLM that contains the solution of the calculation, right? But even if you try very complicated stuff or try to problem solving, ChatGPT is able to do this. But how they did this, no one knows. So this model, was very surprising for many person. This model are trying, you know, to show some intelligence, whatever you want to define the terminology, but they understand in some way, potentially in a completely different meaning of our understanding, because we are human and these are just machine, right? But what the output is the same. They have a result. So how it was able to provide the results, no one knows. And that's why a lot of people are worried about this kind of model, regulation, philosophy question. So it's kind of dangerous territory, I would say. But it's important to understand how the model works in order to use in the best possible way. Because without a basic knowledge, this sounds like magic, right? So you are a black box You put some data, you get the result, but you don't really understand how this is possible, how it works. So just to give you some data, GPT-4 has 1.76 trillion of parameters. So imagine this giant matrix of numbers. More than 120 layers. It can process up to 25K words at once, so in parallel. And to train GPT-4, this is an estimation, because of course OpenAI didn't present the invoice, so how much they spent but more or less these are the numbers. $200 million just to train GPT-4, because they used almost 10K NVIDIA A100 GPU. That was the best GPU available. Just to give you an idea, one of these GPU costs around 25K euro, one. For 11 months, if you do the calculation, more or less, this is the quantity of money. So, long story short, this model requires a lot of power, a lot of CPU. It costs a lot. So only the big tech can afford this. That's why the majority of the model came out by Google, Microsoft, OpenAI, and etc. Meta. This is the size. If we compare GPT-3 and GPT-4, just to give you an image, a picture. So, okay. I hope you have some flavor of what is inside LLM, but how we can use LLM. We need to provide an input. An input is then prompt, and there is this prompt engineering. So forget about PHP, Python engineering, prompt engineering. Unfortunately, in my opinion, there is very less engineering in this sentence. It's just try. That is the engineering part. Let's try. So the prompt is the input. So we call it the prompt. We can say something like, we can ask, where is Geminate located in the solar system? And the model hopefully will get an answer, if knows about the data. Sometimes it can hallucinate. It can, because the model is trying to complete the sentence, and sometimes they invent the response, because the model itself doesn't know nothing about the topics. Oh, that's what we expect to be, you know what I mean? So that's very important. So sometimes this model can hallucinate, can give you answers that are not really correct or are completely false. They are trying to solve this issue, but it's very difficult because it's a neural network. No one knows how it works. So how you can fix it if you don't know how it works, right? I'm pretty sure everyone gets some legacy code and the manager asks you, fix the code. I didn't write it. I don't know how it works. How can I fix it? The same is here. Of course, I'm exaggerating a little bit, but this is very important to understand. So we are playing with technology that we don't fully understand, even the inventor of the technology. So we need to be careful. We need to literally understand deeply the limit of this model. One important thing when you interact with this model is the context window. So the size of the input that you can put in the model. How the model can predict the next word? The output typically is a list of potential words with a probability, right? So in this case, maybe the discussion was around cooking, and the next word can be cake, donut, banana, apple, etc. And then you can see the most probable one is cake, right? So we can say, okay, sounds good, so I can just pick up the best one, right? It seems a reasonable approach. This is called a greedy algorithm. It's pretty standard algorithm in artificial intelligence. I always pick the most probable. And other things that I didn't mention, these are probabilistic model. What it means that sometimes the answer is not correct by design. You cannot have 100% answer correct. In a probabilistic model, you can have the mean of the answer can be 99.999%, 0.5% correct, but there will be always a 0.5, 1%, 2% times that the model will fail. You have considered this when you use this model. Otherwise, you will have a lot of problems. So you need to adjust the application to understand that sometimes it can fail, and you have to manage this fact. So it's a switch change in mentality from an engineering perspective. So I have to use a model that sometimes can fail, so I need to, to challenge my project on this. Okay, so this was the first attempt. Okay, let's try to pick the most probable word. The results were not so good. The results are kind of robotic sentences, not real English like a human, writing. So they did this first approach, and it didn't work. So they decided, okay, let's focus on a different perspective. Let's take the 3 or the 4 or the 5 most probable next word, and from this, just pick up one randomly. Random, it's very, very important when you want to put creative in a software. If you ever program a game, random is one of the most important functions that you have to call in your software. Because without random, you will play always the same game. And here, the same. They put random in this model, and using this approach, the quality of the answer, the quality of the context that this model are able to generate sounds like human. Because we are random people, right? So we are trying to mimicking the human being. It's kind of philosophic talk, right? It's another important parameter is the temperature. So now I say we need random, okay, that's why we can have a generative answer different each time. But we want to trigger parameters. No, we are developers, so we want to change stuff, break stuff. One important parameter is called temperature. So you can actually distribute the probability of the next token in a different way, multiplying by a factor, that is the temperature. So imagine in this example, it's quite evident that cake is the most probable next word, right? If we want to have a model that each time give you a different answer, you can increase this parameter. As you can see, the probability distribution is different. So changing the temperature parameter will change the creativity of the response. So it's important when you want to have something, I don't know, you're writing an application for writing content for a blog post using AI to resentence all the blog posts, whatever. Potentially it's better to have temperature higher. So each time you have different, results, because if the temperature is 0, you will have always the same, almost the same results. If it's more than 0, the output will be different. So this is called prompt engineering. I'll say now we need to understand how to program the LLM. Because if you think 1 minute, okay, we have a CPU, we put program, the CPU run the program and give output. Remove the CPU and put LLM. We put prompt, the LLM does the works and give you a results. They're kinds of similar, right? So prompting is the new coding. It sounds like a religion here, right? So. But, okay, prompt is a new coding, but with coding we have a syntax, we have a technology, methodology, unit testing, right? All this amazing approach. And here, we start from scratch, right? And this started to, the business started, the industry, the academia started to propose, okay, we can define a new language for this kind of model. And there are languages out there where you can basically use prompt as a language itself. This is called in-context learning. So basically the idea is very simple. You have LLM, you put a question, and they give you an answer. Here you can use LLM, for instance, for sentiment analysis. Imagine that you have to, I don't know, implement a system where you want to figure out if a comment or a product, a blog post, whatever, is positive, negative, or neutral, right? So very straightforward example. You can use it and say, look, classify this review. I love this movie, the sentiment, it's supposed to be positive, right? This is called zero-shot inference. So I trust the model, I don't give any example, please do the answer. You can actually provide some example in the context itself. Here, for instance, I'm giving the first example, and I'm asking for the second one. This way, I'm driving the possible alternative words inside this LLM to find potentially the best answer. Long story short, if I give example to this LLM model, since I'm driving the probability less, more example, less space to have as a response, less hallucination, less possible wrong answer. This is maybe the golden rule of prompt engineering. Always try to be very, very precise of what you want. This is called one-shot inference. When you give one example, you can give more example to drive more the LLM to give you an answer, hopefully the right one. Okay, but we are a PHP developer. Stop doing theory, terminology, show me the code, right? Okay, in PHP we have one library that is a community library, not driven by OpenAI. That is OpenAI /PHP/client. That is basically a wrapper against the OpenAI HTTP interface. Thanks to Maduro and Gary, they are two contributors quite popular. They all last year, I think there was Maduro was here, if I remember right. Yeah. So thanks publicly Maduro and Gary for this job, because this is the basic library that everyone at least needs to use in order to communicate with OpenAI. I'm focusing here with the OpenAI. Example, how we can generate a text using this API. We just create an instance of the client. Of course, we need an API key because you have to pay for using this model. You can create inside the chat function. You have to specify the model that you want to use. This is GPT 3.5 Turbo that is right now quite good in many use cases, very cheap. But now you have possibility to use GPT-4, GPT-4o that are quite expensive, I would say, if you double check the price. But you know, you can have different results. You have to try the model. If it works for your cases, that's good. And the message. As you can see, the message is some kind of structured message. It's not just a straight string. Because in the OpenAI API, basically you can have you can specify if you are sending information to the model or if you are sending information as a user. So like a question and you want the answer. This is interesting. So basically I can inform the model how it should behave. In this case, I'm saying with the role system, so I'm talking to the LLM, you are an helpful assistant. It's like giving the introduction of the discussion. You have to be an helpful assistant. And the question is, what is the capital of Italy? And you can give can have an answer, just storing the results. And as you can see, there is this is map 101 with the JSON result of OpenAI. So this is very basic library, just provide you the HTTP connection and some function. So pretty straightforward. If you want to generate an image, pretty straightforward. Another function, images, create, you specify the model, the prompt. This is the prompt that I used to generate the first image that I show you. N is the number of images that you want to produce. You can have, I don't know, 2, 3, 4 different output, and you can give the option to choose the size of the images, the response format. You can choose to have the response on basic 64, so you can put in a file like I did here. By default, it's PNG. You can change the format. There are a lot of possibilities. Very, very simple. You want to text to speech. The example that I give you in the introduction. You specify the model, the input, that is the sentence to have as results. The voice is the name of the actor, artificial intelligence actor. You can, if you go to the OpenAI, in the documentation page, you have a lot of examples you can choose. And one interesting is the speed, because changing the speed of how it's talking, you can have a different, flavor in the conversation. And it's pretty straightforward. You just put in a file. It's by default MP3 file. There are a lot of different formats and so on. So you can see a few lines of code. You can literally do very interesting stuff in your project. Okay, but I don't want to use OpenAI. I'm European. I care about privacy. I don't want to send my data to OpenAI. Right? A lot of people, a lot of regulation, public administration, company say this, right? Okay, we have alternative. For instance, there is this project, Ollama. It's a kind of Docker for LLM, more or less. So it's an utility that you can install locally to download models and to run models. Supports a lot of models. By the way, I will share the slide, and each time you see an underline here, this is a hyperlink to, so you can have all the information. Don't worry. It's a very simple interface. You want to run Llama 3 on your laptop, you have to write this on a command line after you install Ollama, Ollama pool Llama 3. You want to run Llama 3. That's it. If you want to use as an internal model for PHP project, they provide an API interface on localhost on a specific port with the same API of OpenAI. Basically, the majority of the alternative to OpenAI, they just copy the same API of OpenAI. So it's quite simple to switch from one model to another. Okay, another project that I'm involved on is this LLPhant. It's basically a framework in top of OpenAI client. The goal is to have something similar to LangChain for Python. I don't think we will never reach this goal since LangChain for Python is a huge project. We are just a couple of people working on spare time. But anyway, we have this framework. We offer you some function that you can start using it in order to build very, very interesting stuff. We support OpenAI, Ollama, Mistral as vector database, and we'll focus the second part of the presentation on this. We support, of course, Elasticsearch, file memory, Milvus, Quadrant, Redis, and more. We provide the common interfaces in PHP, so you are more than welcome to write your adapter for your specific vector database, LLM model, and I encourage you to have a look at the project and contribute it. The author of this project is Maxime Tonsen. He's a French guy from the Theodore company. Example. Okay, I want to do the same. I want to run Llama 3 on my laptop. I installed Ollama. Everything is ready. I can write a piece of code in PHP using LLPhant. What I have to do is just to create the model, the configuration of Llama 3, and I can just generate the text. That's it. The goal of this library is simplicity. I didn't mention that you can get the response, the original response. You can introspect the JSON. You can know how many tokens did you consume, because here we are talking about tokens, potential token, because this can run on a different cloud system. If it's local, of course, doesn't cost nothing, and etc. So you can start having at least the possible scenario for building an application. Okay, but the very, I would say, interesting use case of this generative AI, in my opinion, is this model. It's kind of framework rather than model. It's retrieval-augmented generation. What does it mean? It means that I want to build a system that is able to search inside a private database using natural languages. So I don't want anymore to have a bar where I need to put the word, the token that I'm looking for, and there is something like select the star from blah, 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 blah. I want something that is semantic. I want something that the user can write in natural languages, in Italian, Spanish, English, whatever, what is looking for. And I want to have results back in my private database. I don't want my data going out my network. That's pretty amazing results, right? If I this sentence 3 years ago, here everyone was just saying, ha 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 ha, this is impossible, right? Now we can do this. So it's basically composed by the retrieval-augmented part and the generation. So the generation is driven by LLM, of course, but as we know, LLM have limitation. There is no source. GPT-4 or Llama 3, whatever, give you an answer, but you don't know where the answer came out. You don't know the document that they use to generate the answer, right? This is giant model that digests a lot of data, and sometimes you have hallucination, as I mentioned. So you cannot have any way to verify that information coming from the LLM and the source. Another problem is the out of date. Typically, these models are trained up to a date. If something happened after, they don't know about this information. And for sure, they don't know about your internal private document, right? So, the idea is to collect a set of data, documents, whatever, putting in a vector database. So you have to use a database that is able to provide semantic search. And the idea is to search into the vector databases, give you the most probable documents that can have similarity with the question, for instance, 3, 4 documents, and put these documents to an LLM using the same question. That's the idea. If you want to picture this, you have a question on the left side. You ask to the database to give you the documents. They provide a subset of documents that are close to the meaning of the question. This subset of documents plus the question is sent to the LLM. And the LLM gives you an answer. How this is possible? This sounds like magic, right? This is possible because we use a vector databases, like Elasticsearch. So a vector database is a system that stores information using a vector. Vector is basically a set of numbers. For instance, a vector of 3 elements, 2, 5, minus 10. This is a vector. A list, an array of numbers, floating point numbers. That's it. For this big model, this array can be very, very big. For instance, GPT uses 1K and half dimensions. So you have to imagine a multi-dimensional space with more than 1K dimensions. So it's pretty impossible, right? Because we are human, and I have also difficulties to figure out the 3D models. So imagine something more than that. But anyway, this is a vector. It's just a list of numbers. Graphically, you can represent with this, line. When we have 2 vectors, so 2 documents, we can ask, okay, the documents are close to each other. That means if the vectors are near each other, are close, that means the semantic of the document are similar. Why this is possible? Because we are using, we can use different approach to measure how the vectors are similar. We can say the angle, the distance, the dot product. Doesn't matter, care a lot. I put this just to give you the idea. So you can, the real idea is the similarity. So you have to check if the 2 points in the dimension are close to each other. You can use different approaches. The operation to translate a sentence into a vector is called an embedding. And here there is an example in 2-dimensional space, so of course it's very limited. But you can see that basically the words that are close to each other in a similarity, in a semantic perspective, they are near each other. So for instance, grandfather, man, adult, woman are in this area. The other, boy, child, infant, girl, are behind. The goal of this model is to group together words, sentences that are meaning to each other. And if the model has a lot of dimension, the probability to have different interpretation is higher because the dimension is so huge that the model can capture all the possible differences in the sentence. Because as we know, when I say something, you can understand something, you can understand something completely different, especially like me. I'm trying to speak English here, so potentially a native English speaker can get something, and an Italian another. So language is difficult, very difficult. You can have different, interpretation. But this model, since they have this possibility, this high multidimensional space, can actually get all the possible deviation of the interpretation and the semantic. That's why they are so powerful. So the idea is to use this database, and at the end of this architecture, what you send to the LLM is a sentence like, given the following context, answer to the following question, where context is the results of the vector databases, the most probable documents. You have to imagine like you are concatenating a string of documents. This is the context, and the question is the original question. As I mentioned, we need to split the documents into chunks because each model has a context window they are different. For instance, GPT 3.4 Turbo has 60K space for the input, so you have to care about this dimension. Okay, I want to give you a very, very quick demo. Hopefully this will work. So let's use ChatGPT 3.5. I'm asking something like, what is the AI Act? ChatGPT say, as of my last update in January 2022, there isn't a singular AI Act. So the model does not know about this document. In fact, the AI Act is a regulation of the European Parliament in July or June, I don't remember. In June of last year. So ChatGPT 3.5 doesn't know this document. In fact, they say, I don't know. I can give you some estimation, potentially something around regulation, but I don't have this model in my inside me, right? That's the answer. What we want to achieve here is to create a system where I put this document in Elasticsearch, in a vector database, and with a couple of lines of code using the PHP, I can actually give an answer because I have the documents. These documents are my private documents, you have to imagine. And using the RAG architecture, I can give an answer. So we are improving GPT 3.5. That's the idea. Okay, so let's see how we can do that. So this is the code. I don't know if it's big enough. No, it's not definitely big enough. Hopefully a little bit. Okay, so basically this is just a simple script. I'm reading the PDF file. LLPhant offer you a couple of connections to read from different sources. This is the PDF one. I'm splitting the document into smaller parts. This is important for the reason that I mentioned. Here we are splitting using 1K words. So I'm looking inside the content of the PDF and I'm chunking in the size of 1K words, where a words is characters between space, comma, and etc. After that, I have to generate embeddings, because inside a vector database, you need to put numbers, right? So we need a way to translate this chunk of sentence into this huge array of numbers. And this is thanks to the neural network model, of course. So we need to use an embedding system. In this case, I'm using the OpenAI. This is another API service that can give you the answer. And at the end, we are just instantiating the client for connecting to Elasticsearch. I'm using an Elastic vector store, and I'm just adding the documents. So the API is quite simple, quite straightforward. So let's see if this is working. So I'm doing live coding, and it's always embarrassing me. Oh, okay, so I'm reading the PDF file. I'm splitting into 56 chunks. So the original documents of the PDF was about 12 pages. So using this, I'm splitting into 56 subparts, the chunk of the documents. Now I'm running the embeddings. So for each of these 56, I'm running an OpenAPI call to OpenAI to give the embeddings back. I get the results, and I index all this information to Elasticsearch. So apparently it works. So now that I have it, I can even check if I have it. This is the interface of Elasticsearch. I should have LLPhant. Yes, I have an index for Elasticsearch. Everything is an index, like a database, more or less, of 1.1 megabyte with 56 indices. So we have it in Elasticsearch. Now what we can do is to try to ask the same question that we give to ChatGPT 3.5. This is the code that I have to write. No, sorry, this is not. Yes, this is the code. The interesting part is this class. So we provide a question answering class where you have to pass the vector store that you are using. Again, you can change Elasticsearch with Redis, whatever you want. We provide the interfaces. Embedding generator, so how the embedding generator works, and the chat. The chat is the LLM model. So you have these three options. After that, you just ask for the question. Let's try if it's working. Okay, seems working. And the answer is, let me try to, sorry, I'm very bad. Usually I have a mouse, a very old man, big screen, different keyboards. So for me, it's like new, this keyboard. The laptop is 3 years old, but the keyboard looks, because I never used. So this is the answer. The AI Act refers to the proposed legislation by the European Parliament aimed to regulation, blah, 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 blah. So it was able to give me the answer, and it also mentioned the documents, the part of the documents that they used to generate the answer. So in this way, we can reduce hallucination, because the model responds only if find the piece of document that are used to give the answer. So this is very, very important. And as you can see, I just, there is a for each loop here with the get retrieved documents function. that give me all the documents that the system used to generate the answer. And I just put here, as you can see, this is the PDF file. So it used 4 documents, the chunk 45, the chunk 26. You can even imagine to create an interfaces, a web interface that you show exactly, you highlight the part of the documents that has been used to generate the answer. So it's a way to trust the tool, right? A lot of companies are just doing this at the moment. They just try to push to develop a product like this for companies. So this is a very interesting use case for Italy. So please go back to your company and try to convince to build this stuff, because everyone is working on this at the moment. So I think it's very interesting, very exciting stuff. Yeah, I think I finished my presentation. Thank you so much.
Thank you. 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 It's working. Okay. Thank you, Enrico. I don't think we have time for questions. So
yeah, I'm at the booth here. If you want to have a chat with me, I will be until the end of the conference. So feel free to ask. And
okay. Thank you again, Enrico. And now we have lunch, so you can go downstairs. Remember that if you have special requirements for food, you can just ask for.